Hello students, welcome back. In this module, what we are gonna do is the continuation of introduction, and it is continuity of a function at a certain point. So, what is exactly it is, as we have seen earlier, but now in a proper conceptual way. What is it? A function y is equal to f of x is said to be continuous at a point x is equal to c in the domain of f of x if we have the equations as follows. All these are the conditions. The first condition says f of c exists. Second condition says limit x is tending towards c, f of x exists. So in first condition a function exists, in second condition its limit is existing. In third condition they both should be equal to each other, that is limit x is tending towards c f of x should be equal to the f of c. That is, if I just want to elaborate it more, what is it exactly? As we have learned in the first module that limit x tends to c f of x exists only when limit x tends to c minus f of x is equal to limit x tends to c plus f of x. That is, the left hand limit should be equal to the right hand limit, and also if these both are equal to f of c, only then I can say that the f of x is continuous at point x is equal to c. So in short, mark this equation very important. The reason is that we would be requiring this equation in the problems. Also, if any point is continuous, then I can say that limit x tends to a minus f of x should be equal to limit x tends to a plus f of x should be equal to f of e. So now let's see what you have understood from this. The first question says f of x is continuous at a point x is equal to c if we know that if an function is continuous at a point x is equal to c, then limit x tends to c f of x should be equal to f of c. But we also know that the limit exists only when the left hand limit and the right hand limit both are equal to the function of c. So I can say equation is limit x is tending towards c minus f of x should be equal to limit x is tending towards c plus f of x, and which is equal to f of c. Moving ahead, sum number 2. If you observe this graph and it's being asked that the given graph at point c is what? Option A, continuous, B, discontinuous, C, both A and B, and D, none of the above. In this case, if you observe very carefully at a point C, there is a gap in between the two lines. That is, while drawing this, you have picked up your pen or pencil. So it is discontinuous. Moving ahead. The third question, it says, limit x tends to a minus f of x is. This is a very simple question for you all now. Limit x tends to a minus. Anything which is minus, well, it is on the left hand side. Hence, the answer is left hand limit. Fourth question. If a function is continuous at a point, then its graph at that point is. See students, if a function is continuous at a certain point, definitely we already have seen in the example that a and f of a, if they are continuous, that is, if a graph is continuous, a function is continuous. Also the vice versa is true. So if a function is continuous at a point, then its graph at a point is always continuous. So students, all these 4 MCQs and the one very standard important formulae is being very important. So see you in the next module. Till then, rise and shine and keep learning. Thank you.